Warm greetings to everyone. Today we are going to discuss about topic called multiplication of large integers. In lower class we have studied multiplication of two numbers, which is quite simple and easy. Let us see an example for it. Let us take two numbers 25 into 15. 5 into 25 is 125. 1 into 25 is 25. If we add it, we will get the answer 375. This method is quite simple, easy, and time complexity is very less. By using this method, we want to find the answer for large integers. It is difficult and we need more time, which we can also say like time complexity is very large. Very large. In order to reduce time complexity and to find out the answer in easier manner, we are going to use divide and conquer rule, which is also called as divide and conquer algorithm. An algorithm which recursively breaks down a problem into two or more simpler problems until these become a simple enough to be solved directly. The solution for the simpler problems are combined together, which gives a solution for the original problem is called as divide and conquer rule. Example, merge sort. It is an unsorted array. We are going to solve it by divide and conquer rule. First, the whole array is divided into two equal parts, and the first part is divided into another two equal parts. Likewise, it divides until it gets a single index. Next, and then two indexes are compared, that is compared and sorted, and compared and sorted. Likewise, first step it will compare and it will sort, and then it will combine into form a single array, and it gives in a sorted manner. With the help of divide and conquer rule, you are going to solve multiplication of large integers. Let us take a number a is equal to 1, 2, 3, 4, 5, 6. B is equal to 7, 8, 6, 9, 3, 2. We are going to solve this in divide and conquer rule method. To solve this in divide and conquer rule or method, we are having a formula A is equal to A1 A0 and B is equal to P1 B0 with and C is equal to A into P, which is equal to A1 10 to the power of n by 2 plus A0 into B1 10 to the power of n by 2 plus B0. We are going to, which is equal to A1 star B1 into 10 to the power of n plus A1 star B0 plus A0 star B1 into 10 to the power of n by 2 plus A0 star B0. We have arrived this term by multiplying this term one by one. Now, this formula is made again into a simpler manner because here we are having 4 times multiplication and 3 times addition, which increase time complexity. In order to reduce that time complexity, we are going to solve this formula into again a simpler manner. Now we are assuming C2 is equal to A1 into B1, C0 is equal to A0 into B0, C1 is equal to A1 plus A0 into B1 plus B0 minus C2 plus C0. Now C2 is equal to now A1 into B1, A1 into B1, which is equal to C2. A0 into B0, which is equal to C0. But these C1 term and this C1 term differs. How it comes? Let us see about it. Now we are going to multiply each and every term with A1 and each and every term with A0, which is equal to A1 into B1 plus A1 into B0 plus A0 into B1 plus A0 into B0. Now we know C2 terms and C0 terms. Imply it C2 is equal to A2 into B1. Wait a minute. Minus C0 is equal to A0 into B0. Cancel these two terms. We will get the answer A1 into B0 plus A0 into plus B0, A0 into B0, sorry, which is equal to C1. That term and this term are same, so we are implying in this term as C1. Here we are having 3 multiplications C1, C2 and C0 and 3 addition, which reduces sometime complexity. We are from this formula we are going to solve multiplication of large integers. Let us assume 1, 2, 3 as A1, 4, 5, 6 as A0, 7, 8, 6 as B1, 9, 3, 2 as B0. By using this formula, we are going to find out the answer for these two numbers by multiplication. Now C2 is equal to A1 into B1, where A1 is equal to 123 into B1 is equal to 786 into 10 to the power of n. Here 10 to the n refers to number of digits, which is equal to 6 here, plus C1 is equal to A1 into B0, where A1 is equal to 123, B0 is equal to 932 plus A0 into B1, where A0 is equal to 456 into 786, 10 to the power of n by 2, where n is equal to 6, 6 by 2 is equal to 3, which is equal to 10 to the power of 3 plus a naught into b naught, where a naught is equal to 456 and b naught is equal to 922. By solving these terms, we will get this answer, which is quite simple than Brutus force analysis. There we are using 3 multiplications and 3 additions. So multiplication of n digit is equal to 3 multiplication of n by 2 digit numbers. We are going to give an analysis by backward substitution rule. Let us assume n is equal to 2 to the power of k. M is equal to 2 to the power of k, which is equal to 3m into 2 to the power of k n minus 1. M into 2 to the power of k minus 2 is equal to 3m into 2 to the power of k minus 3. Substitute 3 into, we will get m is equal to 2 to the power of k minus 1 is equal to 3 into 3 m into 2 to the power of k minus 3, which is equal to 3 square m into 2 to the power of k minus 3. Substitute 4 in 1. M into 2 to the power of k is equal to 3 into 3 square into m into 2 to the power of k minus 3, which is equal to 3 cube into m into 2 to the power of k minus 3. Similarly, m into 2 to the power of k is equal to 3 to the power of 5 into m into k minus I. In general, if we substitute I is equal to k, 3 to the power of k m into 2 to the power of k minus I, we will get 3 to the power of k m into 2 power of k minus k, where k minus k is 0, 2 to the power of 0 is 1, and m of 1 is equal to 1, which is equal to 3 power k. M multiplication of n digits is equal to 3k. Taking log on both sides, we will get k log n is equal to log n to the base 2 is equal to log n to the base 2. N log n to the base 2. N is equal n log n to the base 2. Now n log n to the base 2 is equal to k into n log n into 3 to the base 2, which is equal to n log n to the base 2 is equal to k into n log n 2 log n 3 to the base 2, which is equal to n is equal to n into 1.585, which is where time complexity is lesser than Brutus force method and conventional force method, because for Brutus force and method and conventional force method, time complexity is n square, but for divide and conquer rule method, time complexity is n to the power of 1.585. Thank you.